Hello and welcome back. My name is Matthew. I'm the C# artisan, and this is the 5th video in my series on Azure Service Bus. And it's called Piqued About Peak. So piqued with a QU means mildly irritated or frustrated. And actually, I don't find the whole peak lock methodology irritating or frustrating, but it is a little complex and there are some nuances. So in this video, I'm going to go over some of those complexities, hopefully to keep you from ever feeling piqued about peak. So here's the code as we left it at the end of the last video, where we were testing receive and delete. So let's put it back to peak lock. And let's put our message completion line back in. So to review, what really happens when you receive a message with a peak lock? So when you get the message, a lock is created, and that gives you exclusive access to the message. No one else can receive it. But that lock has a timeout. You don't get to sit on it forever. And if that lock expires, the message is going to go back into the active queue. So let's demonstrate that so you can see how the locks work. And the first thing I need to do is let's put a message in the queue. So there we go. And now let's go look at the queue, and we can see it has an active message. And the thing I want to do is I want to change this message lock duration, so we don't have to wait around for 1 minute. So we'll click change, and we can put it down to 5 seconds, which is the minimum. So now I can sit on the message, but only for 5 seconds. Okay, we have a message in the queue. We've changed our lock duration. Now let's set a breakpoint right here, which is after we've received it, but before we've completed it. And let's run that. So our debug write line happened, and we can see we've received the message, message 1, but we haven't completed it yet. So what this means now is our timeout has expired. And if I attempt to complete the message, I get an exception. Service bus exception. The lock supplied is invalid. Either the lock expired or the message has already been removed from the queue. So that is the behavior when a lock expires on you. And the message is now right back in the queue where we put it. We can refresh and it's available. So now let's go get it. And instead of waiting 5 seconds, let's just run through it more quickly. Okay, we got it and complete it. And now we're done. And if I go back and refresh, that message is gone. So there you go. There's our lock duration and how that works. Now, when a message lock expires, the message goes back into the active queue so that it can be received again. But there's a limit to that, and that is controlled by this setting, the max delivery count. So after 10 times failing the message or receiving and not completing, the message is going to get put in the dead letter queue. So you can configure this as well. And to demonstrate it, I'm going to put it down to 3. And let's go ahead and let's put a fresh message back in the queue. So now we've got a max delivery of 3 and the message count of 1. And I'm going to leave the message lock duration here at 5 seconds. And going back into C#, we need to write a little loop to experiment with this. So how about for int I equals 1, I less than or equal to 4, and you'll see why, and we'll increment. So, and I'm going to, in this case, I'm going to put the breakpoint right here. and I'm going to comment out the line for completing the message. So let's see what this does. So we're going to receive the message and write out its name, message 1, and we're going to wait 5 seconds. And now 5 seconds has elapsed, and let's go again. So when we receive, we get a message because our message went back in, and it's the same one, and it's now been put back twice. So now we're going to loop again. It's been 5 seconds. We receive the message. There it is the third time. Great. And now it should have gone to the dead letter queue. So if I go back to the portal and I refresh, you can see this message is now here in the dead letter queue. So we delivered it 3 times, failed 3 times, now it's gone. And if in my C# code, here when I attempt to receive, it's going to wait 5 seconds because of our timeout. And there's no more messages in the queue. So that explains how this max delivery count works, and it shows you one way that messages can end up in the dead letter queue. Now I want to show you one last thing with regard to this whole timeout and peak lock. So let's say you've got a multi-receiver application. You have one queue with multiple clients pulling messages out. And you might say, why would you ever do that? Well, maybe you've got a microservices environment and you want to scale up because these queue processors are expensive and you want to be able to horizontally scale them. And so you spawn multiple queue readers, and now they are all picking messages off of that same queue. It's kind of like hiring another couple of cooks for your restaurant so that you can process more orders. There's a single order queue, but lots of people can cook the food. So it is a real world scenario. So let's see what happens when one client has a message and another tries to receive. And to illustrate this, I need to set my duration here back up to a minute. I can leave the delivery count the same. And I actually need to put 2 messages in the queue to illustrate the point. So now there should be 2 messages here, message 1 and message 2. And going back to C#, let's make a few changes. So what I want to do here, actually probably to just make this really clear, we won't even do a loop. So we're going to receive the message, but we're not going to complete it. And I'm going to set my breakpoint right there. Okay, we're about to receive it. So we received the message and we just got message 1, and our 1 minute lock has started. And now I'm going to F5 and just let this run out. The portal has no idea that my app is gone. And now I'm going to run it again. So here's a second receiver. And this one got message 2, because message 1, even though it still shows as active in the queue, if we were to go look and refresh this real quick, it would still show you 2 active messages. Well, that's because it timed out and went back in. But in any case, it kind of is in the queue, but it's not available to anyone else. So the next client who tries to get a message is going to get the next message in the queue. And that's kind of the logic of peaking, where each client can actually go up the queue and get other messages, and the later ones may go back in. So what this does, if you think about it, is it kind of breaks the strict first in, first out processing of a queue. It's a behavior you may want, but I don't want you to get peaked and frustrated. So now you know some of the things to look out for and some of the things to plan for if you're going to use peak locks to receive your Azure Service Bus messages.